Hi, everyone. It's great to have you here. I'm Teresa Youngkin, and I'm deeply committed to bridging the gap between technology and healthcare, making it accessible and hopefully impactful for all. You're going to find me here each week helping healthcare leaders stay ahead of the curve when it comes to new technologies. And as an informaticist, I love to bridge technology and the business operations together. Whether you're struggling with data initiatives, you're trying to make informed decisions about new technologies, or if you're just dealing with the constant changes in the market, I got you covered. Welcome to my fall series where I cover my most frequently asked questions on AI. Now, this week's question is, what is AGI and why doesn't it even matter? So, I'm going to give you the quick 30-second spiel about how AGI became the hottest topic to talk about over the last week. Sam Altman, CEO of OpenAI, was fired by his board a couple of Fridays ago. And over the weekend, he was going back to OpenAI, then he was going to Microsoft, and then he was going back to OpenAI. And it kind of went back and forth for about 5 days. And then Sam Altman's back at OpenAI. There's some new board members, and they are chugging along as always. Now, the other thing that we need to do is to walk through the journey of how AI has developed so that you understand what AGI is and why this has got such a huge impact on the conversations as of today. Stage one, these are rule based AI systems, and those are pretty much the foundation of AI. Now, these systems operate on predefined rules or algorithms, and they make decisions based on rules without the ability to adapt or to learn from new scenarios. They are excellent for tasks with clear cut rules like diagnosing a mechanical problem or processing a form, but they lack the ability to learn or understand context. So think of a basic calculator, right? It performs operations like addition or subtraction, and those are based on fixed rules. And it doesn't learn from how you use it or change its responses based on past interactions with you. If you put in 2 plus 2, you're going to get 4. It doesn't matter what kind of day you're having, it's not changing anything, it's not learning anything. The next stage is called context awareness and retention systems. That was the next evolution. And we call that an evolution of AI understanding. Now, when we get past these rule based systems, we enter this realm of context awareness. So, what that means is that you're giving these guide rails to the AI to learn from. That's like when you write a prompt and you say, you are an expert copywriter. Please write me some copy that is engaging and entertaining. So, you're giving it context. This is the parameter and how the AI is supposed to interact. The next part of that is the retention system. So the AI system can also remembers your past interactions, and it uses that particular knowledge and the context that you give it to inform a future response. This is a significant leap from rules-based AI, and it offers a more personalized experience. Think about Spotify. When you get on Spotify, you get all these really great recommendations. It suggests new songs based on your past listening habits, and it learns your preferences over time. It has the ability to look at the past, follow the pattern that you gave it to choose the next best action. The next stage, stage three, is domain specific mastery systems. This is more specialization and expertise in the AI. This is where AI goes deep. These systems aren't generalists, but they're experts and they're fine tuned to excel in specific areas. For example, in medicine, by employing advanced algorithms and machine learning techniques, AI systems can efficiently process and analyze a large volume of medical images, such as dermatology images. The systems are adept at identifying subtle variations in lesion characteristics like size, texture, color, and they can enhance the accuracy of a diagnostic procedure. Some other domain specifics, IBM Watson is one, Google's DeepMind AlphaGo. Those are great examples of these AI's sophisticated abilities to drill down and be very specialized in their fields. The systems themselves, they can analyze vast amounts of data, they can make informed decisions rapidly, and that shows some maturity in AI in some very specific domains. Like I said, medical images is one of them that they've been making really great strides in that. All right, stage 4. This is called thinking and reasoning AI systems, and this is what mimics human thought. Now, this fourth stage starts to go beyond following rules or just retaining context. They actually attempt to simulate the human thought process, and they're trying to understand complex concepts. They're solving unfamiliar problems, and they're also really great at generating creative ideas. Now, this stage represents a significant step towards achieving a level of intelligence that mirrors human capabilities. They function more as an advanced tool than as an equivalent to a human mind. So, ChatGPT is a great example of this stage. It can take the processes that we go through in our mind and it does it at such a rapid rate, we feel like it's thinking just like us. ChatGPT can answer in a certain way and make more valid predictions. All right, let's go on to stage 5. Now, this is where we really start to add fuel to the fire of AI, and it's artificial general intelligence. And that's really about the way that the AI learns and the speed of learning and processing. So, we're going to go back to OpenAI. We're going to talk about QStar real quick. QStar has been able to demonstrate these very intelligent attributes when solving mathematical problems. Math has always been the one kind of key glitch in ChatGPT. Reuters has been putting out interviews with unnamed sources, and that's all that we have to go on, have said that OpenAI has developed this Q star, and everybody's guessing that's AGI because that's what everybody's been waiting for. Why is it so important that this Q star can solve some simple mathematical problems? If a model can solve math, math is the basis of computing and cryptography. That's the underpinning of all of our computing, our national security. Cryptography is at the base of it. The AI, because it is computing so fast, if it goes to solve a problem and it doesn't solve it, it goes right back to a different strategy and it tries to solve it that way. That's thinking. That's the process of thought. So this doesn't work. I'm going back to the beginning. I'm going to try a different route, right? Different strategies until it solves the problem. And it happens so quick. It's bypassing any human speed. It bypasses human thought. So if the algorithm is allowed to continue to learn, it's going to be able to solve math without human intervention. Good or bad? I don't know, but it makes me a little bit weary on the inside because now the computers can process faster and jump ahead of what we're doing. That's really quantum computing. People have said that it's happening. We don't know, and we'll just hang out here and we'll wait and see. Now, the future of AI, that's going to be steps 6 and 7. And they're not here yet, but AGI is the basis for the next two steps, which is ASI, which is artificial superintelligence, and AI singularity. Those start to venture into the realm of science fiction. If computers can solve problems so quickly, they can create new types of math. They can create new paradigms out in the world. It starts to bypass what human intelligence can do. And the singularity represents a future where AI's growth becomes really uncontrollable and irreversible. And that leads to some profound changes in human civilization, if you can think about that. So, is that here? No. Is it possible? Probably. Is AGI the start of it? Most likely. Doesn't mean that's going to happen. This is why I preach about ethical development, ethical standards. Who are the humans who are overseeing that? When we start getting down the path of AGI, the next thing that we can do is to start to build out artificial superintelligence. And then after we have artificial superintelligence, then we've got AI singularity. So it's where the machines are creating themselves. So again, a little bit of science fiction in there. But it's a possibility. So that's why it is on the development path around AI. And this is why people are really concerned about it. It's a valid concern. Now, as we conclude this journey through the 7 stages of AI, it's really clear that AI's potential is really boundless. I. So, in conclusion, are we embracing the AI revolution? Think about it. We've gone through these 7 stages, and it's clear that AI's potential is absolutely boundless. We've traveled from rule based systems to the enigmatic future of AI singularity, and each stage represents a very extraordinary evolution in technology and thought. And I'll go back to an example that everybody uses. We have more technology, more power in our smartphones than we did when we put a man on the moon. Interesting. The role of AI is just going to continue to grow. It's going to bring us some incredible opportunities and it's going to bring us some significant challenges. If this video sparked your curiosity, gave you something to think about, gave you some new insights, I would drop them in the comment below. This is a conversation that we should be having everywhere about AI right now. All right. I'll be here again next week where we're going to answer another FAQ that I'm getting on AI. You guys have a great week. Bye.